Hooray for question 4 of the year 12 thingy test. Octane C8H18 is an important compound in petrol. Identify the homologous series to which octane belongs. Clues in the name, octane, it's an alkane. Write an equation to show the complete combustion of C8H18. Right, well this is just the same as it was at GCSE. We're going to do that, and it's complete combustion, so I make CO2 plus H2O. Right, the trick for complete combustion equations is to just go, well, I've got 8 C's, so I'm going to make 8 CO2s. I've got 18 H's, and there's 2 H's in every H2O, so I'm going to make half of 18 is 9. Now I need to know how many O's I've got. Well, it's 2 times 8 is 16, plus 9 is 25. It's an O, you get 2 O's in every O2, so half of 25 is 12, I can write 12.5. An isomer of octane used to improve the performance of car engines is shown. Give the IUPAC name of this isomer. So here it is, right? And whenever we do a name, we're going to look for the longest chain. And we're going to include the branches, and we're going to look hard. So the obvious way to go is just to go 1, 2, 3, 4. But we could carry on, couldn't we? These look like branches, but that's just the way they've been drawn. So let's go again. 1, 2, 3, 4, 5. Let's go again. 1, 2, 3, 4, 5. Let's try here and go backwards. 1, 2, 3, 4, 5. Let's try here and go backwards again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Every way we're doing it, 1, 2, 3, 4, 5, it's coming out 5s, so it's a pent. There are no double bonds, so it's an alkane, so it's pentan. Are there any other functional groups? There are not any other functional groups, so it's pentane. Now we need to deal with these methyl groups. Looks like there's 1, 2, 3, 4, but are there? Well, it's tempting to say there's 1, 2, 3, 4, and these are definitely 1, 2 here, but let's look here. Right, all they've done is they've drawn this down at right angles to fool you. We could easily swap, because of free rotation, the hydrogen could be there, and the CH3 could be there. Right, so it's 1, 2, 3, 4, 5, it's still a 5 chain, but we've only got 1 methyl group there. And 2 there, so it's a tri-methyl. Could these methyl groups be anywhere else? Well, yes, they could, couldn't they? I could put a methyl group in there, I could move both of them there. They're definitely going to need a number. I'm going to need to be the numbers, the lowest aggregate number. So if I start numbering at this end, this would be 1, 2, 3, 4. And this carbon here would be 5, and so my numbers would be 2, 2, 1, 2, 3, 4 trimethyl pentane. Now I could just try it the other way round. I could say, well, let's make this 1, this 2, this 3, this 4, this 5. What numbers would that spit out? Well, if that was the case, it would be 1. No, it wouldn't. Sorry, it'd be 2. So here's 1, 2, this methyl group's on the second carbon, so it would be 2, 4, 4. 2, 4, 4 gives a total of 8, and 2, 2, 4 gives a total of, I can math. 2, 4, 4 gives a total of 10, 2 plus 4 is 10, and 2 plus 2 plus 4 gives a total of 8. So this is the lowest aggregate number, so it's 2,2,4 trimethylpentane, not 2,4,4 trimethylpentane. Compound X is produced when an alkane is cracked, and we did a bit of cracking at GCSE, so we're not, I'm allowed to put the question in, although we'll do much more of it in the next couple of weeks. Give the IUPAC name for compound X. So we're naming again, we need to find the chain again. So let's find the longest backbone, uninterrupted backbone of carbon. It's 1, 2, 3, 4. Try from the other direction. 1, 2, 3, 4. It's definitely 4, so it's definitely a bute. It's an ene because there's a double bond, so it's a bute It's definitely going to be an EN. Let's look for any other dominant suffixes. No, no other dominant suffixes. In fact, there's nothing there at all, so it's a butene. Now we need to ask ourselves whether this double bond could be anywhere else in this molecule. And the answer is, well, yes, it could, couldn't it? We could leave it, get rid of it there and put it there, and that would be a different thing. So we do need a number. So we'll give it the lowest number possible. We'll start numbering at this end, 1, 2, 3, 4, and the double bond appears first on the carbon, so it's but-1-ene. One molecule of an alkane is cracked to produce one molecule of compound X, so one of these, which is 1, 2, 3, 4, C4H8, I'm guessing, 1, 2, 3, 4, 5, 6, 7, 8, yeah, C4H8. So one molecule of alkane is cracked to produce one molecule of compound X, that's X. One molecule of octane, well, octane is C8H18, 2N plus 2. And one molecule of ethene, well, ethene is C2H4. Deduce the molecular formula of this alkane. So what they're saying here is the alkane was broken up to produce these three molecules. So the total number of carbons we started with must be C4 plus C8 plus C2, so that's C14, and it must have been 8 plus 18, which is 26, plus 4 is 30, H30. And let's just check that makes sense, because we know it's an alkane, so the general formula of an alkane is CnH2n plus 2. Well, 14 is 2 times 14 plus 2 equals 30. That does make sense. So as long as I've done my adding up correctly, yes, C14H30. Is there more? There is more. Compound X has several isomers. The structure of X is repeated here. They've just drawn it for you again because we've changed page. Draw the displayed formula, right? A lot of you are drawing the wrong formulas. What kind of formula? The displayed formula of a chain isomer. So we want a chain, position, functional group. Okay, so it's a but, and it looks like this. For a chain isomer, the first thing we're going to do is we're going to chop off a methyl, and we're going to see if we can put it anywhere else and make it different. Well, if we put it here, we've just made the but chain again. So that doesn't work, so it must be here. That's the only other place we could put it. If we put it here, we've just made a but again, but we've effectively changed the position of the double bond. So no, it's going to be like this. We're going to have C, like that, and very carefully we'll put in the right number carbons. Hydrogen's only 2 there because we've got a double bond. None here because it's 1, 2, 3, 4, and then 3 here and the end. And then we're just going to do a quick count up to make sure it is C4H8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 1, 2, 3, 4. It's definitely C4H8. Now I want a position isomer. Well, a position isomer is moving something around the group that's not, changing the chain. Okay, that would be a chain isomer. So the only thing that we can move around is the double bond. Let's white out my molecule again. We're starting with this. And I want a position isomer. Well, can this thing be anywhere else and be different? Well, it can, can't it? If I put it there, okay, that's different to what I started with. What about if I put it up here? Well, no, that's not different. That's just what we started with, but the other way up. So the only place it can be is in the middle, and we'll do that, like that, and then very carefully put the right number of hydrogens in. It's 3 for that. That one needs 1. That one needs 1. And does it? Yeah, it does. And that one needs 3. Let's just check we're right. 1, 2, 3, 4, 5, 6, 7, 8, C8, H8, brilliant. And 1, 2, 3, 4, C4H8. Now we want a functional group isomer, so we want the same molecular formula, C4H8, but not having the functional group, the alkene functional group. Well, yeah, okay, you knew it or you don't, but if we put the carbons in a ring like this and attach the right number of hydrogens carefully, like that. We no longer have an alkene. We have every carbon with 4 bonds, and we've still got the formula C4H8. Is that it? 8 marks. Happy days. And the computer's gone to sleep.